Welcome to our video series on the path to transactions. As you guys know, MongoDB is coming out with multi-document, multi-statement, multi-collection, transactions across replica sets in MongoDB 4.0. But we didn't get here overnight. There was many projects that had to be implemented in order for us to offer this functionality. And one of those projects was in MongoDB 3.6 Retryable Writes. And Randolph is here to talk to us about this project. I'm Ali Cabral, a product manager on the core server, and this is Randolph, an engineer on the sharding team. So I'm going to toss it off to him and we'll get started.
Sure. Before I begin, I would like to get a brief overview of what Retryable Writes is.
Yep.
So what this allows you is, for example, you send a write to a server. Let's say, for example, the write looks like this. X increment 1. So you incremented the X field by 1. You send this to the server, but before you got the response, the connection was dropped, so you were not able to tell whether you actually successfully applied this right or not.
Right, because that connection could have been lost on my trip there, or on my trip back from the server.
Yeah. So it could have been both ways. Mm-hmm. And what the Retryable Writes allows you to do is to send the same exact write for the second time without the fear of the increment happening twice. Mm-hmm. And before I talk about how we did this, I also want to go to the overview of how replication works in MongoDB. For every single write in a MongoDB like this one, this would correspond to a uplog entry. This is basically a document describing how to perform the exact same write. And this write is idempotent. Mm-hmm. So that means that this will be converted, let's say for example, originally the document was x3 and it becomes x4. So basically the upload document would say set x to 4. So that means that this write will be converted into something idempotent.
So every non-idempotent write is converted to an idempotent write when placed in the oplog because all the other nodes are replicating from the oplog.
Yes.
Okay.
Because the secondaries could apply the writes multiple times, and it has to be. That's
safe.
Why. Yeah.
Yeah, makes sense.
And going here, we have an example where multiple writes has happened on the primary, and the secondary is a node that basically replicates all the writes that happen on the primary. And this is done by basically querying from the primary all the uplog entries that happened. And this is in a very particular order here in this primary: write 1, write 2, write 3, write 4, write 5. And the secondary would extract all these uplog entries and apply in the same order as the primary. Well, I'm simplifying things because there's things that happen in the secondary that kind of paralyzes the application. But for the sake of this discussion, let's say that they're being applied in the same order. And that's how the secondaries copies the primary. Mm-hmm. And with these uplog entries, it has all the writes, description of the write. So what this allows you to do is for every write that has Retryable features on, we could basically look at those uplog entries and figure out whether we have done the write or not. So I'm going to walk through of how the Retryable writes work, and it should be able to give us a glimpse of better understanding of what's happening under the hood. So for example, we're going to use the same example, the increment of x on 1. Let's say we have multiple increments of different fields on different documents, y1, and etc., etc. Mm-hmm. So each of these would correspond to one particular uplog entry. And every time we create a uplog entry on a write that is retryable, we also update the transaction table. What the transaction table contains is the logical session ID, the transaction number of the write, and the link to the last uplog entry that contains the last write of this transaction. So for example, in this case, when we do this write, we created a transaction table linked to this guy. And when we did this update, we created a new entry that links to this, and so on, and so on. And going back to the same example before, where we sent this write, increment x1, then we lost the connection. So what happens when we send the same write again back to the server? What the server will do is it will find out that, oh, this write has an LSID of 10 and transaction number of some number, 20, as for example.
Mm-hmm.
With this, you will be able to look at the transaction table and match the same logical session ID and transaction number. And this will, in turn, point to the last write that happened in this transaction. And with this information, you will be able to inspect all the uplog entries in this chain and see whether it has actually performed this write or not. So in this case, since this particular write is already here, this particular retryable write will not apply the write, since it has already been applied already. And since we didn't apply the write, although we didn't apply the write, we need to be able to still return to the user the response as if we have did the write.
So you want to give them the response they would have gotten if they had been successful on their first attempt.
Yes. So in this particular case, we also embed in this uplog entry all the information that needs to be returned. For example, like we have updated one document, or we have absurd a document. What's the absurd ID? Like everything can be extracted from the uplog entry. There's a special case in a special kind of write we call find and modify.
Mm-hmm.
Because find and modify has an option for you to return the document before the update or document after the update. We have to store this information somehow. And we did this by creating a special uplog entry that is special because unlike other uplog entries that describes what the write has happened, this is a uplog entry that is no up, but contains the pre-image or the post-image of the document after the modification. Mm-hmm. So for a find and modify retryable writes, it will look very much similar to the example I gave earlier, with the exception that it will have a special link to an uplog entry that contains the pre-image or post-image of the modification, so that when we retry the write, we will be able to give you the same response as if you did this for the first time.
Right. So the same success, the client could be unaware that a retry even happened.
Yes.
Because the drivers actually automatically do make one attempt to retry for you when you have the retryable writes option on at the client level.
Okay. So now I would like to talk about how we replicate the transaction table. Mm-hmm. But before that, I'm going to explain what will happen if we replicate the transaction table the normal way. And so if we're going to do this the normal way, we have, let's say, for example, multiple writes for transaction 10, contains write1 and write2. So this means that the primary will contain the upload entry for write1 and write2, and then the update to the transaction table. So what this would look like in the primary is we have write1 here, and we did write2, and this has a link to the previous write1, and we write the transaction table here that contains the link to write2. So this is what the primary state would look like. And if the secondary is replicating the upload entries from the primary, then it would have applied write1 and write2 as well. However, if this primary goes down before the secondary was able to fetch the update to the transaction table, then the secondary will not contain this particular state, which has the transaction table entry that is supposed to link to the last write. So what will happen is if a new primary goes down and this becomes a new primary, and new writes happen along, then this particular update to the transaction table would have been lost. And this is bad because if you sent the same exact transaction, this transaction, to here to do a retry, the secondary has applied write1 and write2, but it has forgot that he's applied because it doesn't have the transaction table entry. So what will happen is if you retry this, the secondary would look like this: W1, W2, and then W1 and W2 again.
It would reapply those rights even though it had already successfully applied them.
Yes. So this is bad.
Yeah.
In order to get around this, what we did instead is we don't replicate the transaction table normally. What we did is for every single upload entry, it also contains all the information the secondary needs to be able to form the chain and update the transaction table correctly. So what it will look like is like W1, W2, and some other writes, let's say W4. And when the secondaries apply these writes, fetch these upload entries, and try to apply them, each individual upload entry would also contain all the information the secondary needs to construct the transaction table. What this means is if this applies W1, it would look like this. It will apply W1, and it has all the information it needs to be able to construct the transaction table and point the write one. And when it applies write2, it will then apply write2 here, and it has all the information it needs to update the transaction table and point to write2.
And that information is the logical session ID or the LSID and the transaction ID?
Yes.
Okay.
And we also have like a unique identifier for every single write.
Oh, okay. The statement ID?
Yes, the statement ID. This is kind of internal
Right.
bookkeeping.
So statement ID is the internal statement within a transaction. Transaction ID is the sequence of statements, I guess. And
Yes.
then the logical session could have multiple transactions within a session.
Yes.
Got it.
And we also have in order to keep the memory low we also clean up every entry when you bump up the transaction number. So we only keep track of the latest logical session ID with the latest transaction number. So say for example, you have here LSID, some ID, and transaction 10. And then you start a new transaction 11, with the same ID, this will get overridden. So basically, we're assuming that if you start a new transaction with the same ID, you you don't care about the older transactions anymore.
And a session ID or a logical session ID is tied to like one thread, so it has to be like a sequential operation.
Yes.
Got it. Makes sense.
So this is pretty much how retriable writes work in the server 3.6.
Awesome. Thank you so much, Randolph, for walking us through this. Great.